Okay, we're going to start off with direct variation. There's a couple of things that you need to know about direct variation. The first one is that it always passes through the origin, which remember is the point 0, 0. So it's always going to go through the origin, no matter what. If it's a straight line, goes through the origin, boom, it is a direct variation. In terms of when you think direct, you should be thinking divide. And the reason is because the ratio is y over x, okay? That's our constant, oops, that's our ratio. So our constant of variation, and I know I'm throwing a lot of words at you right now, but believe me, I'll tie it all together. Your constant of variation is going to be your k, which is equal once again to that ratio, which is y over x, okay? Make sure you're careful. It's y over x, not x over y. So y over x. Your constant of variation for direct variation is just a fancy way of saying slope, okay? And if you think about slope, I mean, isn't slope rise over run? So the change of y over the change of x. So it's that same kind of thing. The equation for direct variation is y equals kx. Now remember, it goes through the origin, which is that plus 0, so that's not written, but it's understood. And then the k is that y over x, which remember, it's really just the same thing as slope. So here's all of our different things. When we graph it, it doesn't matter if it's going to be a positive, a negative, whatever. It has to go through the origin. That's the first thing you look for. So that would be an example. That would be an example. The second I move it, if it doesn't go through the origin, it's not a direct variation. It's just a line at that point. It's just linear. So it has to go through the origin. All right, let's do some examples. So there's a couple different things that they could ask us for in terms of direct variation. They could say, find the constant of variation and then write the equation. And they're telling us once again that it's direct. So let's start with this first one. So the constant of variation is y over x. So y over x is 4 over 1. So my constant of variation is 4. Now, if you're asking yourself, Miss Beck, can I choose any point? Absolutely, boo-boo, you do you. This is 8 divided by 2. Guess what? That's 4. This is 12 divided by 3. Guess what? That's 4. Okay, I just like to take the first point because I'm lazy, and I just like to be straightforward. So just grab that k equals 4. Done. Okay. Now, in terms of, so that's our constant of variation. So I would write k equals 4. Then it also says to write the equation that goes with that. So our direct variation equation is y equals k over x. I just plug in 4. So y equals 4x. That's my equation. We can do the exact same thing from a table, because these are just a fancier way of seeing a bunch of points. So for constant of variation, it's y over x. Once again, it's going to go ahead and grab that first point. So it's negative 8 over negative 12, which is going to be a positive. And then if I go ahead and reduce 8/12, it should be 2/3. Okay. If you don't believe me, math frack it and see. Here's another biggie. Remember I told you the direct variation always goes through the origin? Boom. There we go. So we know that that's a direct variation. And then we go from here. So if k equals 2/3, let's actually rewrite that so we know it's nice and neat. And they say, okay, well, now write the direct variation equation that goes with it. That's the parent function. So now I just go ahead and plug it on in. That's my equation. All right. They could also say find the missing values for the direct variation. So we know that for direct means divide, so y over x. We're going to take each point and just make it a proportion. So negative 4 divided by 2 equals y divided by negative 6. Cross multiply it up. 2 times y is 2y. Negative 4 times negative 6 is a positive 24. Divide both sides by 2. My missing y value is 12. Same thing. Find the missing y value. Okay, so it's y over x. So y over 12. Oops, and I wrote it wrong. Y over 12 equals 7 divided by 4. Cross multiply. So 4 times y is 4y. 7 times 12, what is that, 84? I hope so. 7 times 2, yeah, 84. Divide both sides by 4. Y equals 21. I'm going to go ahead and make these 2 ordered pairs because for me, it's easier to see them as ordered pairs. So if y equals, so here's, I'm going to make it into 2 ordered pairs. If y equals negative 18 and x equals 3, find x when y equals 30. Okay, so it's a direct variation, so it's y over x. So negative 18 over 3 is equal to 30 over x. So cross multiply, negative 18 times x is negative 18x. 3 times 30 is 90. Divide both sides by negative 18. And what do we get? Negative 5. X equals negative 5. That's my missing value. Okay? All right, so in terms of graphing, this is just really a friendly reminder of slope-intercept, to be honest with you. Now it'll say, graph the direct variation. So this is the same thing as y equals mx plus b. If I don't have a b, go ahead and just put plus 0 if you want to. If you don't need to, it's fine. So I know if it's a direct variation, it goes to the origin. So that's my first point. That's my b. And then I just take my slope, which in terms of direct variation is just my constant variation, and I put it over 1. So that would be negative 2, or I rise negative 2, go over 1, fall to 1, fall to 1, and then do the opposite. Connect your dots. Has to go through the origin. Has to go through the origin. All right, let's talk about inverse. Okay, so inverse variation never goes through the origin. It's also really weird looking. I'm going to show you one in a second. You will be expected to graph direct variation. You will not be expected to graph inverse variation, even though you definitely could, and it wouldn't be that big of a deal. In terms of when you do inverse, you multiply. So your ratio or your constant of variation is x times y. Here's where people get a little weird or get confused. The equation for inverse variation is y equals k over x. So a lot of times people get confused because they're like, well, Miss Beck, y equals k over x, that's divide. No. Okay, so your constant variation, you multiply, then you're just going to plug into your inverse variation equation. Okay? The graph of an inverse variation looks like this. I just need you to be able to identify. So it never goes through the origin, and it does this weird kind of like U-shaped thing, and it mirrors itself on the other side. It could be, that close. It could be, no, I'm trying to get it. Well, I guess technically that would work because it's just not going through the origin. It could be on the other side as well. So it's like those two, like this kind of like it wants to be an X, but it's not, kind of converging. It's two like lines, they're separated. All right, so let's find the constant of variation for the inverse. The good thing about inverse is you just multiply, so it's nice and easy. So the constant of variation is just x times y. So 2 times 12 is 24. Miss Beck, will that work with everyone? Yep, 3 times 8 is 24, 4 times 6 is 24. Our inverse variation equation is y equals k over x. So I just plug in my k over there. So y equals, literally just plugging in 24 right here. So 24 over x. That's my equation. All right, same thing. So inverse means multiply. So my k is equal to x times y. So k is equal to negative 2 times 18, which is equal to a negative 36. I plug into my inverse variation equation, which is that one, and I just plug in k. So y equals negative 36 over x. Done. All right, we're going to find the missing value. Okay, so the k for inverse, we just multiply. So I would say, okay, 4 times 12 is equal to 3 times y. So 4 times 12 is 48. 3 times y is 3y. Divide both sides by 3. Y is equal to 16, right? It's 48. Hold on, let me check that. Last thing I want to do is have to make another video because I didn't do it right. All right, good. Next one. Constant of variation is x times y. So 6 times y is equal to 7 times 9. 6 times y is 6y. 7 times 9 is 63. Divide both sides by 6. Y equals 10 and a half, which if we math frac that one is 21 halves. Don't do decimals. Don't do it. And last one for inverse. I would say, okay, I'm going to make these into points because it's way easier for me. So find x when y is equal to 4 if y equals negative 8 and x equals negative 3. Okay, it's an inverse variation, so that's x times y. So x times 4 is equal to negative 3 times negative 8. X times 4 is 4x. Negative 3 times negative 8 is a positive 24. Divide both sides by 4. X equals 6. All right, that's it.